What's up, math fans? Pop quiz. Look at these two triangles. Are they congruent? Yes or no? Look at them. Well, you've been learning about congruence. You've been learning about what congruence means. You've been learning that this symbol means congruence. You've been learning that for two shapes to be congruent, all the sides and all the angles have to be congruent. So you need all three pairs of corresponding angles and all three pairs of corresponding sides to all be congruent. And if you look at this, I didn't give you all three pairs of anything. I didn't give you enough information. Or did I? Then I made a video where I introduced proving two triangles are congruent using side, side, side. And I explained that you don't need all 6 pieces of information. There are shortcuts. And one of the shortcuts was using side, side, side. Now I'm going to show you that another shortcut is using angle, side, angle. So if you look at this, 70 degrees is corresponding and congruent to 70 degrees over here. In fact, I'll call the base AB and the vertex C. Here I'll call it X, Y, Z. So A is corresponding and congruent to X, B is corresponding and congruent to Y, and C and Z, you don't know anything. You can infer that they are also corresponding and congruent. We talked about that with similar triangles. So I have an angle corresponding and congruent to an angle, that's A. Another angle corresponding and congruent to another angle, that's A. And I have, if you're going in order, and in this case I'm going kind of like in a loop. So what is this? Counterclockwise. And this matches with this, and then I went in a loop this way. So technically, I look at this angle, and then the very next thing I should be looking at is not this angle. It should be this side. I look at this angle, and the very next thing I should be looking at is this side. And look at that, 1 centimeter, 1 centimeter. So the corresponding sides are also congruent. So I have angle, side, and then the third angle comes, and then the third angle comes. I'm sorry, the second angle comes, or the third piece of information. So this is an example of angle, side, angle, congruent to angle, side, angle. Is this enough information? Well, obviously there's a video about it. It is. And you can kind of tell looking at my example that even though you only see these 3 pieces of information, if you know this is 70 and 70, you know it's isosceles, so you know those legs are the same, which means you know these legs are the same. So you do have side, 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 and you do have side, side, side. And I explained that side, side, side is good. So if side, side, side is good, angle, side, angle is just a hidden version of side, side, side. So I don't even need to get into that when I'm doing it. I don't need to explain that again. Once you agree with me, angle, side, angle works, you're good. If you have angle, side, angle, congruent to angle, side, angle, that means the sides are locked in, which means that other angle is locked in, which means they're congruent. So angle, side, angle is a shortcut for proof. Oh, proof? Did somebody say proof? I will prove something. Here's a question. Take a look at these two, and I'm going to give them different letters just for fun. So again, let's go ABC and XYZ. And the question might be simply, prove triangle ABC is congruent to triangle XYZ. So you take a look at it and you ask yourself some questions. Can I prove it, first of all? Is it true? Can I prove it? How do I prove it? What do I see? How do I know? All right? So let me get this out of your way. And you start to formulate a proof. And if you have ever seen a formal proof before, formal proof means you say something, you explain it. You say something, that's your statement, and then you explain it, that's your reason. So what would you like to say? You should usually say what you see. I'm looking at this thing, what do I see? Oh no, I didn't put a loop here, sorry. But that doesn't really matter. If you see 120, you see 120, right away you should be able to say, number 1, angle B is congruent to corresponding angle Y. Why? Why would you say that? Oh, they're both 120. It's obvious. It's given. It was in the question already. It's given. Do you see anything else? I see it 2 meters here and 2 meters here. That means BC is congruent to YZ. BC is congruent to YZ. That's number 2. How could you say that? How dare you say that? Right? It's right there. It's part of the question. If it's part of the question, it's given. Given. Do you see anything else? Yes, you do, hopefully, or else you can zoom in. 30, 30, right? That means that angle C is congruent to angle Z. Why would you say that? Hopefully you caught the pattern by now. It's also given. If it was in the picture, if it was part of the problem, it's given. A lot of people like to say stuff that they know, but it's not in the picture. Only if it's in the picture is it given. Or sometimes they might actually put words and say, you know, angle B is congruent to angle Y. But that's part of the question. It's given. If you know it, if you infer it, if you assume it, it's not given. Then you have to explain why you're saying what you're saying. What's my goal? To prove this? Is this enough information? Let me see. Angle, side, angle. Counterclockwise. Angle, side, angle. Counterclockwise. Hey, it works. You go in order, you go corresponding, and if you have enough information, then you can conclude triangle ABC is congruent to triangle XYZ. Triangle XYZ. Why would you say that? Because angle, side, angle, postulate of congruency is enough to prove your point. That's it. It's a very basic proof. It will get a lot more complicated. Right now, I just want you to see how to start a proof. Usually, the harder proofs, they don't spell it out for you this easy. You have to actually figure it out. You might see something called a bisector or a median or a midpoint, and you have to know that this half equals this half, or it's isosceles. So they're throwing more higher vocabulary at you. Right now, just basic, everything's given. Then they might confuse you even further, and they might do this. They might say 3x minus 2 and x plus 1.6. 3x minus 2 and x plus 1.6. And instead of saying prove this, or they might say prove this, and then they'll say solve for x. So you might be looking at this thing and you're like, what does solving for x have anything to do with anything? I don't know anything about x. But you do, because once you can prove that the two triangles are the same, that means what I said earlier, all parts are the same. Now you know, this is what you know, all parts of, I missed a word, all corresponding parts of congruent triangles are congruent. I said that in the beginning. I said if they're congruent, that means all the angles are congruent and all the sides are congruent. So this equals this. You make a very simple equation. 3x minus 2 equals x plus 1.6, and then you solve for x. So there's all kinds of tricky ways to play with this thing. It's not just one step and you're done. There's different ways to think about it and different things you can do with it. All right? So hopefully you understand a couple of shortcuts. We got side, side, side. We got angle, side, angle. Are there other shortcuts? Oh, I don't know. I think so. Stay tuned. Thanks for watching. See ya.